talking about games on Linux, finally. Eric's working at Intel Open Source Technology Center. I'll pass it on to Eric now.
Thank you. Yeah, so I do work for Intel's Open Source Technology Center. I've been working on Linux graphics drivers. Note that I don't actually do graphics on Linux, so this presentation is going to be a little bare bones here. I've been working on graphics drivers now for 7 years at Intel. At the start, the job of the graphics team was to do the entire graphics driver, and the graphics team was me and Keith, so we got to work on absolutely every part of the stack. These days, I mostly get to work on Mesa's OpenGL drivers, which is really what I've always been interested in, and I'm free to actually work on that now. My original motivation in getting into open source back when I was in high school was I wanted to play games on alternative operating systems. And the problem at the time, there were a few games, but the graphics drivers were in such bad shape that I ended up working on graphics drivers instead of playing games. Over the last 7 years, we've made some pretty big changes in the stack. You've probably heard some other presentations about them. Early development was getting memory management so that we could actually reliably talk about memory on the graphics card even when there's multiple processes. Kernel mode settings so that finally displays work and I can just plug in a projector and everything runs. On the OpenGL side, we've made some pretty big advances. Back when I started, we were something like 10 years behind. No modern game ran on Linux. It was OpenGL 2.1 maybe. We didn't even have OpenGL ES, which is what all of your Android phones are running, so there were just huge markets that were not available because we didn't have OpenGL for it. But in the last 7 years, we've actually got now OpenGL ES 2.0 conformant, certified by Kronos. We have like actual OpenGL, and we can say the word OpenGL now. And we just submitted results for OpenGL ES 3.0. But I still never played games. And I've tried a lot of open source games, and at one point even tried to work on an open source game project, and they've never seemed to get as far as you might hope. It seems like it's really hard to build a team for working on an open source game. You know, on a lot of our projects, we start with something very small to scratch our own little itch, to build some tool to get some job done. But as a game designer, you need to not just be able to be a programmer, you also need to get 3D models or rasterized images or things that are hand-drawn, and how many in the room do that? I see a hand. And even if you do manage to get a bunch of people to think they're going to cooperate and let's build a game together, we've got artists, we've got developers, it's really hard to agree on a direction because while so much of open source software is objective, this driver needs to be able to have this functionality, this application needs to be able to let me present on a monitor. In a game, the design space is so huge that getting a bunch of developers to agree on what game you're actually building is pretty difficult. And the other problem is that a lot of our motivation in open source is to scratch our own itch. But as a game developer, you're not having a lot of fun playing your game. Actually, becoming a developer makes it harder for you to do the thing that you were trying to do, which is enjoy playing a game. Despite that, we had a few things. ET Racer, we've seen a few times before. That was something that I think started out closed and got opened as PP Racer. Open Arena started out closed. It was the Quake release. A few actually, from the start open projects, Foo, Billard, Neverball, Cubes, and Warsaw, Westnoth. How many people play these games regularly? A few hands, sweet. But that's not many of us. And then there were some closed source games. I noted the Quake release before. If you take the original art assets from Doom 3, Quake 4, the engine's been opened. You can actually play those games on Linux with native binaries. UT 2004 was never opened. It's still closed source. There were a bunch of old games from Loki back when they existed that were porting other games to Linux and making Linux-only CD releases, and it was really cool at the time, except they never made much money and failed. Minecraft is actually a success. I think, how many people play Minecraft? Yeah, that's pretty cool. If I say Linux games for a year ago, it's like Minecraft was the Linux game, I think. And then there were a bunch of things that you could maybe force to work using Wine. And after you've spent 2 days fighting with an installer trying to get your game to run, it's not much fun anymore. And then along came the Humble Indie Bundle. This started in May 2010 with a game developer, an indie game developer who wanted to get his game out there. He'd seen the success of Steam's cheap bundled sales of games where they get a bunch of collection of things and say, hey, for only $10 you get all this cool stuff. And they managed to get sales that they wouldn't otherwise for various games by bundling and making it look like a really sweet deal. And they've actually released some surprisingly good titles for Linux. These are a few of them that are some of my favorites that I would highly recommend. Psychonauts, Torchlight, Trine. Braid was one that I'd been hoping for on Linux for a long time. I'd seen the game design, and it's really cool. And they learned an important lesson from Braid. The Braid developer, Jonathan Blow, back in 2008 was trying to port his game to Linux. And he put up this blog post, this very earnest question of, I'm trying to do a game on Linux. How should I build my game for Linux? Things like, how do I deal with mouse grabs? How do I keep, when you have a window and the game is taking all of your input, how do I keep the cursor in the window so it doesn't wander over somewhere else and send my clicks to some other window? And how do I get the motion events within that window in a way that doesn't get clipped to the size of the window and mess up your input? And how do I output sound on Linux? This is really hard. So he asked this question, and of course, if you ask a nice technical question, very detailed in the right forum in the Linux community, he got answers. 251 answers. And pretty much every possible answer. For sound, it was, you should use ALSA directly, or OpenAL, or SDL directly, even though you've noticed that it has some problems. But actually, no, you should use Pulse Audio directly, or Port Audio, or Jack. The only one I could think of that I didn't see mentioned, there was Arts and eSound. Those two didn't get mentioned, but every possibility. And then for input, it was the same story of all the different things you should try. And he gave up. He said, you know what? This Linux market wasn't that big. It's costing me a lot of time that I'd rather be spending on something else. Maybe I'll try again later. Sorry, guys. The Humble Bundle folks learned a lesson from this, which is don't bother the game developer with porting to Linux. They want to be building a game. They don't want to be figuring out a million different platforms. Let's have a guy that has already ported a bunch of games to Linux, just port everybody's games to Linux. This is Ryan C. Gordon, has been doing a lot of it, also known as Iculus. He's done a lot of the Quake ports. Anytime there's a giant code dump of source into open source for games, pretty much he's usually the guy that gets it to actually build reliably and figure out how to distribute the binaries and all that sort of stuff. And in that process, he's learned how do you actually build games for Linux, because there are a lot of weird things you have to deal with, like how do you do sound reliably? How do you make binaries that will actually keep working 5 years from now, which was a failure with a bunch of the Loki games where they were still learning the process, and they're really hard to run now. You have to scrape up old binaries, and it's a mess. What surprised me, we got involved in the beta process for the Humble Indie Bundle. The beta process is literally like there's a Google Docs with a link to Dropbox stuff, and for bug reports, you just type in the document of like, my name is Eric, and it spits this error when I try to start the program. It's a very minimal process. What amazed me was that it's a really short turnaround. From the time when they get a port of the Linux game running and post it on their beta document, it's about 2 weeks from we have binaries that work to shipping it in a Humble Indie Bundle. It's remarkable to me how successful they've been at getting things to run reliably across a wide variety of Linux systems in such a short period of time. Most of the bugs that are dealt with in the beta are just distribution issues of, oh, it turns out that this distro has renamed this library to this, and you can't dynamically link to it, and so you need to bundle it, that sort of stuff. And perhaps even more exciting was this summer's interactions with Valve software. There have been petitions for Valve to port Steam to Linux for as long as I've been involved, for at least as long as Steam's been around. We actually got to start working with Valve Software back in July when they were still, even before their closed beta period. So we actually got to drive up to Seattle and hang out with a bunch of guys in their offices and work on porting Left 4 Dead 2 to Linux. It started out a little rough, bunch of bugs, things were really dark in the game. But it was a really good interaction to actually work with a game developer directly for the first time in a very productive manner where we can actually say to them, hey, you're doing this thing to our driver and it's really inefficient. And if you just use this other code path that OpenGL offers you, it'll work a lot better on Intel. Interestingly, the response was usually that, yeah, we had tried that before, but NVIDIA told us to do it this way instead. They opened their beta in early November, they opened up their closed beta in early November and started an open beta in late December. The things that they ported initially was just the source engine in Left 4 Dead 2, and then they released that as the Team Fortress 2 port in their beta. And what filled out the rest of their list of games in those betas was actually the Humble Indie Bundle games, where the Humble Bundle guys don't really want to be in the distribution process and maintaining games and figuring out how to get updates to people. It's really manual. You go to their website and click on some deb and install it, and it complains about a bunch of missing dependencies, and it's all pretty miserable. Now that they've shoveled that problem over to Valve Software, it's like you just click on the game and it opens. So this is what's available on my system currently. The left side is all that list of games, and I actually don't even have on there all the games that I have access to because I haven't got around to putting the last Humble Indie Bundle on there because I've been too busy. But yes, that's games on Linux. You can actually just open this app, click games that you've purchased, and run them. In the process of working with Valve, though, we learned a lot of things that they were really disappointed with. In the Windows development environment for OpenGL, there's this extension called arb debug output, which you might think of kind of like perf events, where somebody in some layer of the stack gets to put in this trace point that says, send this string and it's this class of event, a performance event or an error or something. And it's this sort of priority. And then the application gets all these events out of the system that say, oh, you're hitting this slow path a lot. And this is a really important thing to have on Windows where you don't really have the console so much. We're used to printf debugging, and for them, they actually need a callback to get it into their application's logging infrastructure. We have an implementation of this extension in Mesa for our debug output. It was contributed by an independent contributor. And it only has 2 events, which are just the normal OpenGL errors that you can already get out of the system anyway by asking. So we can tell you about out of memory, and we can tell you about something else that you did that was invalid in the spec, and that's it. They were a little disappointed in that. The other part was bad debugging tools. We went there and they sort of asked us, okay, here are some tools we use on Windows. What's the equivalent thing you have on Linux? And we were very excited. API Trace is this new thing. It's so cool. And it's been helping us a lot. So we showed it to them. And they looked at us like we were crazy. Because for us as driver developers, API Trace is awesome, right? I want to get your app out of the way. I don't want to have to go through menus and click things. I want a reproducible trace of what your application did to me. And I can use it for performance work of making sure I can get that set of calls done as quickly as possible, or I can use it for debugging of figuring out which call it was that did something wrong in my driver. But throwing away everything the application does is really bad for an application developer because the performance stuff they're looking at is all the stuff in their application. They don't care about the driver because they don't think they can change it. So here's the tool we have at the moment for performance analysis on Linux. This is a tool in API Trace where after you've taken a trace of your application, you can load it up in QAPI Trace. It takes a while. And then you can run this profile tool, and it takes a long time. And then you get this out, which is identities of shaders on the left. The red is times that those shaders were running on the GPU. And up at the top is OpenGL calls and the time they took on the CPU. And if you put a lot of effort in, you can probably identify that there are times when the GPU wasn't busy, and maybe you should figure out what was going on there. Or times when an OpenGL call took an insanely long time, and maybe you should figure that out. But it's really hard to correlate events of figuring out, like, well, the GPU was idle here, and what was the CPU doing during that time that might have caused that to happen? We don't have any analysis like this. On the Windows side, they have pretty interesting tools, things that let you insert into, first of all, you run the application, and it's some sort of LD preload style thing that just inserts itself into the application as it's running and captures events out. And they let the user put in trace points in their application that say, oh, by the way, I'm starting to draw the world, and right now I'm drawing this character, and right now I'm drawing his helmet, whatever. And so you get a hierarchical view of what's going on in the system so that the application developer can figure out, oh, it looks like the problem is that helmets are really slow to draw, or something. So we have a lot of work to do here. We need a trace tool that can work while the application is running. We need to be able to get events out of the application and figure out what ways they already have for doing this so that we can implement those and get their events that they've already written. Yeah, tracing is hard. The other thing they complained about was that Mesa is just really slow. There's this big shared OpenGL core that's pretty correct these days. We have an actually conformant implementation, but a lot of these paths are not very well optimized. There's these huge switch statements that have a bunch of conditionals within them of like, okay, but you can't use this enum if you have this set of extensions exposed, and everything is way more expensive than you might expect. And instead of telling us, hey, you guys need to get the cost of your OpenGL calls down, what they said is, everybody else just doesn't bother with that. All they do is they take your OpenGL calls coming in and insert a layer. Every OpenGL implementation has this dispatch table, giant table of function pointers, and when you call GL begin, all that GL begin is look up this entry in the function table and call that thing. So given that we already have this table of function pointers, I can slip in a new table of function pointers that just saves off which call you made, what its arguments were, any data and any pointers that there were into some sort of batch buffer. I can queue up a bunch of those in user space, hand that off to another thread and say, hey, could you go make these OpenGL calls for me? Or the idea, sometimes that'll just be too slow, right? When the user asks to submit 10 megabytes of data directly, I probably don't want to copy that and then tell another thread to copy that into the GPU. Maybe I should just do that right now by synchronizing with the other thread and getting the job done. Paul Berry at Intel did a bunch of work on this. There's a bunch of nasty code generation. There's some scary Python involved. And he actually got something running that actually moves all your OpenGL off to another thread. Pretty exciting. Unfortunately, it's not very fast right now. It uses multiple cores, but it doesn't use multiple cores faster than a single core. And some of that might be a problem directly related to integrated graphics. On a discrete card, it makes a lot of sense to, if the CPU is idle and the GPU is busy, use a bunch more CPU, and it doesn't even matter because the CPU is this large resource. When we're dealing with integrated graphics, if I do any extra work that hits memory, that's a resource that's not only shared with my OpenGL driver work, it's also shared with the GPU. And so it might be that my CPU is slow just because my GPU is trashing my CPU's caches all the time. So inserting this extra buffer where I'm using a bunch of extra cache space on my buffer isn't helping me with my memory bandwidth problems. There is a branch up which actually implements GL threading. It pretty much works. It passes the test suite. It just needs some love to figure out how to make it run faster than single-threaded performance. But I don't want to end on a totally down note. There were some big surprises while we were there that as open source developers, things that we're so used to that they haven't experienced before. One was short development cycles. Closed source drivers are massive things. I think I've heard the IMG driver is on the order of 1 million lines of code. I don't imagine that NVIDIA is any smaller. These drivers are very large things that take a lot of understanding and effort to do anything in. Our open source drivers, it's like 250,000 lines of code for all of Mesa, and my driver itself is 60,000 lines of code. When they asked me for performance events through ARB debug, I said, well, okay, our debug isn't too great right now, but I can give you an environment variable that tells you about performance issues. And they said, well, I don't care how you give me the information as long as I can get information. And in 30 minutes, I was able to hand them, here's a driver that prints performance issues of a bunch of things that I know about that you can do to my, do to my driver that would be bad for you. And sure enough, we printed out a bunch of stuff, found that they were stalling on the GPU in various places, found that they were not getting fast clears in some places. And it was amazing to them that we can turn around new development that quickly working with them. And environment variables for debugging, that we can take the same driver that we're using normally, flip a little switch, and totally change its behavior. Track a bunch of state to figure out what's being changed, print out that performance information is now landed upstream. We have stuff for printing out the contents of your shaders, of what actually got compiled for the GPU. Nobody else lets you see the assembly that got compiled for the GPU. They give you some sort of mid-level representation, maybe. Those were things that were really cool for them, to be able to say, look, here is the code that is compiled based on what you submitted in your shader. And the most surprising thing to me, because I take them for granted, was breakpoints. At one point, we're having a little argument of, you're using this interface wrong, and he says, no, look, I have all this code. It uses the interface right. It sets these flags here and these flags here. And I said, well, look, GDB the application, and we break on the function and say, oh, look, you're setting the wrong flags here. And here's the call chain back up to what you did to me. And his eyes lit up, like, you can do that? And furthermore, the point where we take a couple of steps and we see that, oh, here's the code path that's blocking on the GPU, and here's a comment explaining why you're doing that. They don't have visibility into their drivers that they use on a regular basis in the Windows world, right? All they have is they try something and it's slow, or they try something and it's fast, and they build up a mental model out of that of what the driver is actually doing underneath them. And it's pretty mysterious sometimes. Apparently, on NVIDIA, if you submit more than a certain amount of data in a single buffer upload call, it's wildly slower. No idea why, so you just chunk it up into multiple small uploads and it seems to work. If it was open source software, you would have seen that statement there and figured out why in the world things go slow when you're over 128K. So it's been really exciting working with actual developers. It's been kind of eye-opening for us to see the things they care about, debugging, and being able to actually interact closely with someone on being able to change what the applications do to a driver instead of just saying the application is a static thing that I can't modify. So yeah, that's the story of games on Linux now. Questions?
Anyone have questions?